All right, let's get started, folks. Let's stop talking, please. So, talking about graphing tangents and cotangents. Let me grab a picture. Yep, we're graphing for the next couple of days. So let me grab a picture of a tangent graph. All right. So here is a graph of y equals tangent x. So I want to talk a little bit about some important features of the tangent function. First off, we already know that tangent is odd. So odd functions have origin symmetry. So if we rotate this graph around the origin, it looks exactly the same. Another important thing about the tangent function is it is increasing. So it goes uphill from left to right, always. And we get these repeating patterns here. The period of tangent is pi. Now, tangent is a combination of sines and cosines. If you look at the unit circle, you'll see that the tangent function, the values of the tangent function repeat every pi units. So in contrast with sines and cosines, the period of tangent is pi rather than pi over 2. Because the tangent function we can think of it as sine x over cosine x, we had points when we talked about the unit circle where the tangent function tangent was undefined, or tangent of an angle was undefined. Well, if we think of this as a function where the tangent function is undefined, we're going to get vertical asymptotes. So because of this, we get vertical asymptotes when cosine x equals 0. And we know from our unit circle that is when x equals pi over 2, or 3 pi over 2, or 5 pi over 2, or 7 pi over 2. So we can keep adding multiples of pi to that, and we still get asymptotes, vertical asymptotes. And here n equals plus or minus 1, plus or minus 2, etc. So these odd multiples of pi over 2, we get the cosine equals 0. We're going to get vertical asymptotes at all those places. Yes?
So what if cosine doesn't equal 0?
Well, that's where we get this. That's where our graph actually does have, where we actually get a graph. So the reason I mentioned this is we're locating the asymptotes is going to be part of how we sketch the graph of the tangent function. So we want to be able to find the asymptotes. So from this graph, we call this a branch of the tangent function. We get one period from negative pi over 2, that vertical asymptote, to positive pi over 2, that vertical asymptote. And we're going to repeat every pi units. So the asymptotes are one period apart. So that's one period of the tangent function. And it's going to repeat over here and continue. So we're going to use this information to help us sketch the graph. All right, are we good with this information? So we're going to put all the transformations that we can do to the tangent function all together because we know in general what the different things do to the function. So we're going to put them all together. And in some ways, tangent and cotangent are less complicated to graph than sines and cosines, but there's a few details that we have to keep track of because it's a different kind of function. All right, so to graph, y equals, and I'm going to put all the transformations in, d plus a tangent bx minus c. Just like we did with sines and cosines, I'm going to immediately rewrite that. And I'm going to factor out that b. And write it like this. D gives us a vertical shift. A, it doesn't really make sense to talk about the amplitude of the tangent function because it approaches positive infinity and negative infinity. So we're just going to call A the vertical stretch. And we'll talk about how we deal with that vertical stretch in just a minute. Our period. So for sines and cosines, it was 2 pi over b. For tangent, our period is pi over b. And our horizontal shift is c over b, just like with sines and cosines. But we need to account for the asymptotes because asymptotes are going to change when we do these transformations to this function. So what we're going to do to sketch the graph is find 2 successive asymptotes. Successive just means one after the other. By solving, bx minus c equals negative pi over 2 because our unshifted tangent function has an asymptote at negative pi over 2, and this bx minus c tells us how our function is shifting. That has to do with the horizontal shifting. That also tells us how the asymptote is going to shift. And bx minus c equals positive pi over 2. Because the unshifted tangent function has a vertical asymptote at positive pi over 2. The bx minus c term tells us how that asymptote is going to shift when we transform the function. We're going to have an intercept halfway between the asymptotes. And then to account for our vertical stretch, y equals plus or minus a halfway between the intercept and the asymptotes. So once we get that, I'm going to go back to our graph and show you what that means. All right, so if I go back here, what that means is halfway between the intercept and the asymptote, so this is 0, 0. Halfway between 0 and pi over 2 is pi over 4. This y value here, these aren't to scale here. These are, the axes are scaled in terms of pi. So this point here would be at y equals 1. And this point here at negative pi over 4 would be at y equals negative 1. So that's how we account for the stretch. If a is larger, those points get shifted up here and down here, and the graph is more stretched out. If a is smaller, or a fraction, those points would shift down towards the x-axis, and we'd get a more flattened out tangent curve there in the middle. So the key to graphing tangents and cotangents is finding the asymptotes. And then we end up dividing things in half a lot because we're finding the middles of things for tangents and cotangents. So I want to go through a couple of examples of sketching the graph of a tangent graph, tangent function. And then once we know about tangent functions, cotangent is really almost exactly the same. They're just a couple small changes. All right, so questions on our details here? All right, so let's take a look at a graph.
No, he was legitimately not playing all that well. Like he's like legit.
What's that? I'm not feeling well, so we all have to learn math. All right, so
I feel fine. Can I not?
Yeah. Great.
well, that's a perfect combination, because I'm ready to teach you a lot of math, and you're ready to learn a lot of math.
I think the second part of that is like
All right, so we're sketching graphs just like we did yesterday, so I'm not going to sketch a graph for all of this. So here, A is 1, B is 2, so our period is pi over 2. Now normally, or not normally, with a sine and cosine, our period is 2 pi. So we find our period by 2 pi over b.
why is A
Oh,
one?
sorry, a is 2.
I was like, I doubled him down.
So it's good. That shows me that you're all paying attention.
It was a test. No worries.
Yeah, that's right. All right, we're going to find our asymptotes. We're going to say 2x equals negative pi over 2. The 2x, this piece tells us all the horizontal stuff that's going to happen to our graph, including the asymptotes. So this tells me x equals negative pi over 4. And we're going to say 2x equals positive pi over 2. So the negative pi over 2 and positive pi over 2, where our asymptotes are for an unshifted tangent function, the 2x tells us how they're going to change. So we get pi over 4. And one way to check to make sure we've done this correctly, it should be one period between the asymptotes. Negative pi over 4 to pi over 4 is pi over 2 units. So we got one period there. All right, so let's sketch a graph. So I usually exaggerate the size of my x-axis when I'm graphing tangents and cotangents, because you need a lot of space in here to label points. So this is at pi over 4. This is at negative pi over 4. We get an intercept halfway between, so it's 0, 0. Halfway between the intercept and the asymptote, so at pi over 8 and negative pi over 8, we're going to be 2 units up and 2 units down. And tangent is increasing, so we get a point here, and we get a point here. And then I'm just going to make a nice smooth curve between my asymptotes. Make that point a little bigger. And there would be one period of that tangent graph. If we want to sketch 2 periods, we're going to move everything over 1 period. So 1 period pi over 2, pi over 4 plus pi over 2. So pi over 4 plus 2 pi over 4. So we're at 3 pi over 4. Halfway between pi over 4 and 3 pi over 4. And if we're not sure, if we can't think of it in our head, we can always find the midpoint. So to find the midpoint between pi over 4 plus 3 pi over 4 divided by 2, that's how we find a midpoint. So we have pi over 4, 4 pi over 4 divided by 2, so we get pi over 2. And then we can either shift this point over by pi over 2 units and this point over by pi over 2 units, or we can find the middle of pi over 2 and 3 pi over 4 and pi over 4 and pi over 2. Either way we can do that. So let's shift this over by pi over 2 units. Pi over 8 plus pi over 2. Well, pi over 2 is 4 pi over 8, so we get 5 pi over 8. And negative pi over 4 plus 4 pi over 8 is 3 pi over 8. So we get a point up here at y equals 2 here. There's my intercept. A point at negative 2 there. And there is my second period of that tangent function. All right, questions there? All right, let's look at one where there's a little more going on with our tangent function, and then we'll talk about cotangent. So we want to sketch a graph of y equals 2 tangent 2x minus pi over 2. I'm immediately going to rewrite that as 2 tangent of 2 times x minus pi over 4. So we have a equals 2, b equals 2. So our period, pi over 2. Pi over b. We're going to shift right by pi over 4. And now let's find our asymptotes. We're going to say 2x minus pi over 2 equals negative pi over 2. So we add pi over 2 to both sides, divide by 2. I get x equals 0. And we're going to say 2x minus pi over 2 equals positive pi over 2. Because this tells us how the function shifts, including the asymptotes. So I get 2x equals pi. So x equals pi over 2. It should be 1 period between the two asymptotes. And my 1 period is pi over 2. So that looks good. So now we're ready to sketch our graph. Here's my vertical asymptote at x equals 0. Here's one at x equals pi over 2. We get an intercept halfway between 0 and pi over 2. So at pi over 4. And we take care of our stretch. So we're going to go up 2 units and down 2 units. Halfway between the intercept and the asymptote. So pi over 8. and 3 pi over 8. So I'm going to go up 2 units here and down 2 units here since tangent is increasing. And then make a nice curve between the asymptotes. There would be one period. This one I think it's easier to do instead of doing the period forward. We know that this is, we can go in the negative direction and just make everything negative. Because we have that symmetry. So this would be negative pi over 2, negative pi over 4, negative pi over 8, negative 3 pi over 8. Doing this one kind of fast. And there's another branch there for my second period. And that would be 2 periods of my tangent function. Lots of dividing things in half with tangents and cotangents. All right, questions there? Yes?
So you kept mentioning that because it's increasing, is there a scenario where it decreases?
Tangent function, no. Unless if we did a reflection over the x-axis, then it would decrease. But tangent function, if we're not reflecting, if we're just shifting, it's always going to be an increasing function. And that's one of the differences between tangent and cotangent. So let's talk about cotangent. So let me grab a picture of a cotangent graph. All right, so there is y equals cotangent x. So some important facts about the cotangent function. We know that cotangent is odd. So odd functions have origin symmetry. So if we rotated this, here's our origin. If we rotated this around the origin, we'd get this branch that's over here, and it would look exactly the same. Cotangent functions are decreasing. So they go downhill from left to right. Cotangent of x equals, we know, cosine over sine. We know that cotangent is undefined at points on the unit circle. Well, those points are where sine x equals 0. So we're going to get vertical asymptotes where the sine function equals 0. And sine x equals 0 at multiples of pi, whole multiples of pi. So for this unshifted cotangent function, we see it has a vertical asymptote at x equals 0. So 0 pi, and x equals 1 pi. So we have our asymptotes at slightly different places. Oh, and I forgot one thing. Period is pi. Just like the tangent function. All right, so for graphing cotangent functions, the only thing that is different is where we find the asymptotes. Everything else is the same. So what I'm going to say is, to graph y equals d plus a cotangent bx minus c, which I would immediately rewrite as a cotangent bx minus c over b. We find successive asymptotes. By solving bx minus c equals 0, because our unshifted cotangent function has a vertical asymptote at 0, and the bx minus c tells us how the function and the asymptotes are going to change, and bx minus c equals pi, because that's where our unshifted cotangent function has a vertical asymptote. The bx minus c tells us how they're going to shift around. Everything else is the same as for tangent. And when we mark those points to account for a vertical stretch halfway between the intercept and the asymptote, this time we make them go downhill. So we're going to be higher on the left than we are on the right to make our graph go downhill. But everything else that we do, we find the points in exactly the same way. So I just want to do one example with a cotangent graph so we can see the process. Any questions on this information? So we're sketching. Three cotangent x plus pi over 2. So a equals 3. We shift pi over 2 to the left. Period equals pi. Find our asymptotes. Yes?
Is there abbreviation that you want us to use for asymptotes, or is it just asymptotes?
I don't.
No? Okay.
Yeah. X plus. Sorry, my brain went off in a weird direction. X plus pi over 2 equals 0. So we get x equals negative pi over 2, and x plus pi over 2 equals pi. So 2 pi over 2 minus pi over 2 is 1 pi over 2. And we'll check our work. Distance between negative pi over 2 and pi over 2, pi units, 1 period, so that's good. So there's negative pi over 2. I usually kind of exaggerate the scale just so I have room to put all my points in there. Our intercept is going to be here at 0, 0. We're going to have these account for a vertical stretch at these points halfway. Let me move this up. Halfway between the intercepts and the asymptotes. So we're going to go up 3 here and down 3. And we want it to go downhill now. We want it to be decreasing. So my point here is going to be there. And my point here is going to be down here. And then I just make a nice smooth curve between the two asymptotes. And there would be one branch of that cotangent function. One period. And if I wanted to sketch another period, I would shift all of these points over by one period. So I'm just going to fill them in what they would be. So my next asymptote is at 3 pi over 2. Halfway between pi over 2 and 3 pi over 2 is pi. And then this is going to be 5 pi over 4 and 3 pi over 4. Intercept there, up 3 units there, down 3 units there. And there would be my second period of that cotangent function. All right, questions? Okay. On Monday, we'll talk about secants and cosecants. Wait, I made a mistake here.
Bailey's there, you're there.
I made a mistake. Let me see where I went wrong.
So yeah, it's gonna be really cool. Like what position? So what do you want?
You describe what they are.
Okay, so there's 2 stations. So there's a cashier.
Sorry, I started writing down problems from the other problem set.
And then there's a person who runs and gets the orders. And then there's 2 people on pieces. And then there's 2 people on refilling the.
Which one do you think will be
The most fun runners are fun. But it's like talking to people.
I feel like I like talking to people. I write things down.
I'm pretty sure you're probably Ellie, right? She and I are
Okay,
so can I write your writer?
All right, there we go. I got it right that time.